Hello everyone, so in this video let us talk about an easy problem from LeetCode. The problem name is sort array by parity. So the problem goes like this, that you're given an integer array nums, move all the even integers at the beginning of an array followed by all the odd integers. So you are given some integer array as you can see, and you have to move all the even on the very front and then the odd numbers. So return any array that satisfies this condition. You can return an array, and there are up to 5,000 elements. Now you can pause this video, try to find out the solution of your own as well. But let's take the first example only. So 3 1 2 3 1 2 4. Now I have to bring out all the even elements first. So it should be like one of the case can be to bring out these elements at the very first. So I should bring these elements at the very first and just swap out these odd elements at the back. So this give me one of the observation that I can use some sort of a two-pointer technique, and I can swap out the characters or the elements. If they are not even, if they're odd, we will put it in the very back, and if it is even, we can just leave it down there. So let's make this example a little bit bigger, and let us try to use this example that whether it is working or not. Okay, so what we'll do is that let's increment this value. So let's say the array is let's like this. Okay, and okay, let's take this example. So let's say we'll take two pointers. We'll take one pointer at the very end and the one pointer at the very start, because I want to first initialize or bring the even numbers at the very front. So what I'll do is that I will check that whether this is an even number, this is not. So I will swap this number with the very last number. Okay, if I just swap this out, it will become like this. It will become like, I'll just remove this. This will become 3. This will become 2. Okay, now what will happen is, because I've swapped, I eventually know that this is the number which has come from the very back. It might be even or odd because it is coming from the very back. I've only checked this front number. This front number is having the condition that if it is an odd, put this number in the very back. You got the point? So if this is an odd number, I've inserted it at and swapped it with the last pointer value, like whatever this pointer is holding out, and bring this value at the very front. Now it might be happen that this might be also odd, so the odd number might have come again. So I should not move this pointer ahead, but I should only move this pointer ahead. Why? Because it eventually means that this number is odd and it has come to the very back. So now let us move down this pointer to the very start. So now my pointers has moved like this. This has remained to the same point, but this has moved. Now whether the first point is even. If it is even, then we just move our first pointer to the right hand side. Okay, so we'll move our first pointer to the right hand side. Whether the first point is even. If it is even, we just keep on moving the first pointer to the right hand side. Okay. Now whether this is even. This is not even. So I will swap this with this. Okay, because I want to somehow bring an even number if it exists on the second pointer. Now if I swap them out, both of them are 3 only. So what will happen is that 3 will swap with 3. And nothing will change, but I will not move this element, because what you have observed is that by swapping this, I want to somehow make this even to like for that odd number to an even number. But because the other pointer is also holding an odd number, this will not change anything. But when I have switched this, I will not move this pointer, but I will eventually move this pointer. And now they have come to the same point, which means that all the elements on the left hand side of this kind pointer are even. All the pointers on the right, like all the value on the right hand side of this particular point are odd. So we have, and both have come to the same point. So which means that we have done iteration. All of them are even, all of them are odd on the left and right side. That is done. So that's the overall thing. We'll use two pointer technique to do overall all this overall thing. So let us move on to the actual code, how it actually works out. So we have two pointers. One is I, that is the very front, and n is the very end. Okay, so this is 0 and the size of the array. Now this is a while loop till I is less than n, so that we will keep on doing this iteration. If the current ith element, the first element, okay, or the first pointer that is holding the element, if it is an odd number, then what I'll do is I will swap the first element, that is the pointer that is holding the first element, and the last and the second pointer value, both of them are swapped, and then n is moved to one step on the left hand side, which is the second pointer is moved to the left hand side. And similarly, you can see that I am also moving my I on the right hand side, but in the after this if condition, it is moved back. Why this is moved back? What I'm trying to do is that I want to nullify the effect when I'm swapping, so that only the right pointer moves. But if we are not going inside this if condition, which means that when I'm doing this while loop, if the left pointer is pointing towards an element that is already even, this is only going in the odd condition. We are only swapping the first value with the second value if it is an odd, so that my first value will not remain to be an odd value. So if it is an even value already, I will just move my right or the first point to this, like the first value pointer to just the next element. So I'll just move my I plus plus. Eventually they both move, these two pointers move around this whole array, and when they comes to the same point, this value will break and we have the whole bifurcation of even and odd elements inside the array. And that's the overall solution. You will just return the new modified array nums. That's the overall logic. So this is an O of n operation by moving out both the pointers over this whole array, and we have not used any extra space as it. So this is an O of n time complexity problem. So that's the overall logic and the code part for this particular problem. If you still have any doubts, you can mention down in the comment box of this particular problem. Thank you for watching this video till the end. I will see you in the next one. Coding, and bye.